Section 4.2 is going to talk about how to graph a linear equation. So let's start by talking about what a graph of a linear equation actually is. The graph of a linear equation will form a line, but what it really represents is a set of all points in a coordinate plane that represent all solutions of an equation. I can assure you my real handwriting looks so much better than this, but I apologize, so thanks for bearing with me. So the example we're going to look at, we're going to take this equation and we're going to graph it. Notice, unlike the problems that we've been given before, it doesn't specify for a given domain. So that should tell us something about what our graph is going to look like. The first step is going to be to solve the equation for y, or to rewrite it to get y by itself. We see that we have y being added to negative 2x. If I want to isolate my variable, I'm going to add 2x to both sides so that I can get y by itself. I'm going to end up with negative 3 plus 2x, but we know we want that x term first, so I'm going to write it as 2x minus 3, or plus a negative 3. That would be the same thing. Step 2, we are going to make a table by choosing. We get to make a choice because they didn't tell us in the problem. We get to choose what values we would like to use for x. I'm going to pick negative 2, negative 1, 0, 1, 2. That's a good standard set of x values. There are times when I would pick something other than those values to plug in for x. Negative 2 times 2 is negative 4, minus 3 is negative 7. I'm going to plug the rest of them in. I'm going to get negative 5, negative 3, negative 1, and positive 1. Next step we're going to do is we're going to plot those points. Once we plot our points, we notice that all the points appear on a line. We're going to connect the points by drawing a line through them. We're going to use arrows to indicate that it goes on forever because there are an infinite number of solutions. Because the way the problem was phrased, it's not actually asking you for a specific domain. There's nothing here to tell us that. So we want to indicate that although we picked these 5 points, that there are many other points that we could have picked as well. So I'm going to pick this. I'm going to extend my line all the way through my graph. I want to make sure that my line has arrows on both ends. So for me, I'm going to have to go into Properties and change that real fast. And let's change that color to red. So when we look at our equation, we have an equation that goes through our points. It has arrows on the ends and extends through our graph. The next example we're going to look at is, what if our equation looks a little bit different? What if we have something like y equals 2? Well, if I just pick any x values, let's pick my negative 2, negative 1, 0, 1, 2, there really is no place for me to plug them in this equation. But the equation does tell me that y is always equal to 2. So I'm going to go ahead and fill that in here. What does that look like? Negative 2, 2, negative 1, 2. Hopefully we'll start to realize that this is going to form a line, and that line is going to be horizontal. So again, let's take our line. We're going to extend it through our graph. We're going to make sure that we have arrows on both sides. And for some reason, this does not want to change this for me. Okay, you guys should know. Then you can put an arrow on both sides, okay, and extend it through the line. All right, I'm going to pick, for the next one, it tells me that all of my x values have to be -1. Well, that means that I'm not picking x values now. Now I'm picking y values to figure out which points to plot. Sorry, I had a brain fart there. So now my first point is going to be -1, -2. Then I'm going to plot -1, -1, -1, 0, -1, 1, and -1, 2. You quickly realize that this is not going to be a horizontal line, as our first one was, but rather a vertical line. So I'm going to take my line, let's move it over. You should make sure that you have an arrow on the end of it. So let me just write that arrow in up here. Okay, and then the question is, which equation is a function, which is not, and why not? I want you to think about that. If you have to go back to your notes from section 1.6 or 1.7, where we talked about what a function is or isn't, okay, we also talked about a visual way to tell whether or not something is a function. So I'm actually going to leave that question with you. Okay, the last example that we're going to go through and talk about is graphing a function for a given domain. So if I look at my first example here, I have y equals -1/2 x plus 4. It gives me the domain, or it gives me my x values as -4, -2, 0, 2, and 4. When I plug them in, I'm going to get values of 6, 5, 4, 3, and 2. For the graph of this function, again, you're going to go and plot those points. I'm going back -4 and up +6, -2, +5, 0, 4, 2, 3, and 4, 2. Although this does form a line, they are asking me specifically to graph it for the given domain. So I am going to leave this as points only. My second example, I have that same equation, and if I do not give you a domain, it's understood that the domain is going to be all real numbers. So I'm actually going to use the same points that I used above. I'm going to be using these points. 1, 2, 3, 4, 5, 6. But this time, because my domain is all real numbers, I am going to draw a line in. Draw that line in, make sure that you extend it for all of your graph, and make sure that you give me arrows on the end. And let's look at our last example. Here we have the same function, but this time the domain is given to me as x is greater than or equal to 0. So if I were to look at my original set of values up here, I could not use my first 2 points. I could use my others, so I could go to 0, 4, 2, 3, and 4, 2. And this time I want to highlight all of the places, okay, where x is greater than 0. And I don't, want to create my graph where x would be less than 0. So I'm actually going to have a ray rather than a line for that point.